Good morning my dear friends. Welcome you all to part 5 HVAC cooling load calculation video. So till part 4 we have completed room internal sensible load and now we started room external sensible load. So in the room external sensible load we finished the exposed wall temperature differential for material specification, and last time I asked the question, the last part that why we need to add the correction temperature along with the temperature differential value. So first of all we use page number 60 to career handbook, a table to find out the exposed wall temperature differential. For example, if I open this table, so if you see the equivalent temperature difference, and the important point here is you need to see this temperature condition. So they have mentioned like 95-degree outdoor design temperature, 80-degree room temperature and 20-degree daily range. Okay, so but in our case Dubai, we are following the outdoor design temperature like 115 and the indoor temperature like 75 and daily range is 25. So these values are not matching with what the standard is given. So there should be some temperature to adjust the value, that is called as a correction temperature. So as I mentioned here, these correction temperature values are added for the exposed item like glass, roof and external wall. So we found out only the external wall. So now we can add the correction factor along with this one. So before adding we need to find out what is the correction value for the Dubai. Okay, because each country there will be some correction value. So we'll initially find out the Dubai value. And for the correction temperature, we need to refer page number 64, table 20A, career handbook. So this is the table 20A and page number 64. If you see here, outdoor temperature minus indoor temperature at 3 p.m. Okay, so that means for the Dubai 115 outdoor temperature, indoor temperature is 75. So different is 40-degree Fahrenheit. So we need to consider here. And here the daily range they have given in Fahrenheit. So based on the municipality data, the daily range for Dubai is 13.8 degrees Celsius or 25 degrees Fahrenheit. So now we can find out the value. So here now the outdoor minus indoor is 40 degree Fahrenheit and the daily range it is 25 degree Fahrenheit. So it is between the 24 and 26. So we can see the value 23 and 22. We can take the average. So 23 plus 22 divided by 2. So the correction value for the Dubai is 22.5 is a fixed value for each country. Okay, so now we need to add this correction value with the temperature differential value. So we know that this 19.5, all this answer we got from the last video. So for the all the direction, east, the west, north and south, and we need to add this correction value to this factor. So if you add this one, you can get this different value. So based on the project requirement, so we need to see how many exposed wall we have. So wherever we have exposed wall, we need to consider that one for the formula. So we'll see that one how to consider. And next one is the same step we have to repeat. Temperature differential we have to find out, then again correction value. Okay, so first we will see what is the temperature differential for the roof. So we need to refer page number 63 and table 20. So this is page number this is table 20, equivalent temperature for the roof. Okay, so here also if you see the outdoor and indoor temperature, the same issue we have, that's the reason we are adding the correction factor here. Okay, so let's see, first it is exposed to roof, and in our case now what happened, we have the G+5. Okay, so there is no roof exposure for the ground floor because we are doing the ground floor room number 5. So in our case we don't have any exposure, but if you have any exposure you need to know how to consider. Okay, so that's the reason I'm just adding here. So exposure to sun here. So we need to see the building weight. So it is concrete 4-inch 47 and exposed to sun. We are just assuming that this is exposed to sun. Okay, so we need to see the if you see here, and the case here exposed to sun first, and between building weight is between 40 to 60. Our case is 47 and 3 p.m. we have to select. So it is between 33 and 31. Okay, so 33 plus 31 divided by 2, it will be 32. So with this 32, I am adding the correction factor, the same value what we added for the wall. So 32 plus 22.5, 54.5. This is for the roof. So the next one is for the glass. So we need to refer page number 46. So if you see this table 15, solar heat gain through ordinary class, there are different latitude angles given. Like if you see here, this is 10 degree north latitude, and if you go down, and it is 20 degree north latitude here. So similar way 20, then 30, then if you see here 40. So different values are here. For the Dubai it is 25 degree. Okay, so 25 degree falls between 20 and 30. So now the question is we need to consider the higher one or lower one. So the answer here is, for example here for Dubai it is 25 degree north. If latitude increases, temperature will go down. That means for us it is 25. So if you go to next one like 30 degree Fahrenheit, 30 degree north, so the temperature will go down. Okay, so we need to consider the lower one for the safe side. That means instead of for the 25 we need to consider 20, not 30. And for the Dubai, we can experience the higher temperature in the July month. So we will go with this table, 20 degree north latitude and July month. So for all the direction we will take, then we will see in what wall we have the glasses. Okay. So first one is the east. If you see here at 3 p.m. we need to take the answer. So 3 p.m. it is 13. The next one for the south at the same 3 p.m. 13. Then if you go to west, it will be 1:45. Then we have one more thing, north. So north it is 17. Okay. So now with this answer, what we got now, I am adding the correction value 22.5 for with all the direction. So finally we got the answer here. Okay. So in this table I added the temperature differential with the correction value. Okay. So together in a same table. So now we got the answer for all the numbers. So we can apply the formulas here. So Q is equal to UA delta T. First we need to see the external wall, how many exposure we have. So in this our example, if you see here, we have two exposure, one from the north side, one from the west side. So we will apply the related value here to find out the answer. And here the west wall is 20 feet length and the north wall is 13 feet length, and the height we know that is 9.84. So the first one is U value. So U value, the previous videos we found from the table. So the U value for the external wall, it is 0.25. So next one is the area. So area 20 feet is the length and 9.84 is the height. Then delta T. So delta T just now we got from the table. Delta T for the external wall, if you see the direction is the west. So that one will be 10. So with correction factor 22.5, total it is 32.5. So similarly for the north wall, Q is equal to UA delta T, U the same U value, and with we know that 13 feet into height 9.84 and delta T from the above table it is 24.5. Okay, so total west and north wall we got the answer for the external wall. So next to that we need to find out the glass. So glass, there are two things. One is the radiation because of the sun solar load, and also there will be heat transfer from external to internal. So it will be a transmission load. So there are two type of load you have to consider only for the glass. So the same thing, Q glass radiation in north side first. So in our example, if you see here in the north side, we have one window with 2 into 2 feet sizes. So for the north exposure glass, so U value 0.59 from our earlier table 0.59, and the area it is 2 into 2 feet, so total 4 feet, and the delta T for the glass in the north direction, if you go here for the glass in the north it is 39.5. okay, so we can apply all the value here. So for the north it's 93.22. so this is the radiation load, as I mentioned earlier, radiation as well as transmission because of the outside to internal temperature that we need to apply. So here delta T we took from the above table, but when come to the transmission load, it's simply the outside temperature minus indoor temperature. Okay, so that means the delta T for this one will be 40 degree Fahrenheit. Okay, so here will be U, A and delta T. So it is 94.4 BTU per hour. The total, the glass heat transfer is equal to radiation load plus transmission load. So total these two values give the answer of 187.62 BTU per hour. And the final one is the roof. So as I mentioned in our case, we don't have any exposed roof, because the case here is this is the ground floor and we have first floor, second floor, third floor. So we don't have any exposed roof, but I'm just adding this one for your understanding. So it's the same formula, Q is equal to UA into delta T, and the U value for the roof, earlier we found that for the roof it is 0.2. okay, then the area, so our room area 20 into 13 feet, so 260 square feet, and delta T, if you go above from here for the roof, you can, okay, from here temperature differential for the material specification for the exposed roof, so 32 plus the correction 22.5, total it is 54.5. so now we finalized all the external sensible load. So total sensible external sensible load is equal to external wall, then glass and roof. So roof it is 0, so I just made it 0. For the wall there are two sides. Okay, so this answer is for two sides and this is for the glass. Okay, so finally we got 2570.13 BTU per hour as a external sensible load. So already in the previous video we found internal sensible load, so now we can add both. And finally we have one more balance, that is the, now we know external sensible load, internal sensible load, so we need to find out external to internal sensible load because of the untreated air. So thank you for watching the video. If you have any comment, please add your comment in the comment section. So we will meet again in the next video. So till then, bye bye, see you.